Hello mathematicians, this is 10.2 for algebra, quadratic functions. Now in 10.1 we worked with quadratic functions and we drew tables and we graphed them. Now they're going to show you another way to graph them, and it is by finding the vertex. So here is the graph of a quadratic function. This is a key concept or property. The graph of y equals ax plus bx plus c has the line x equals negative b over 2a as its axis of symmetry. The x coordinate of the vertex is negative b over 2a. So write down this equation, x equals negative b over 2a. That is my x coordinate of my axis of symmetry, or of my vertex. So remember that when you have a quadratic function, the first one next to the x squared is a, the one next to the x is b, and the number by itself is c. So when I go to do this equation, I'm going to say x equals negative 4, because b is 4, divided by 2 times 2. So that equals negative 4 over 4, which equals negative 1. So if I were to say, or if they were to say, what's the axis of symmetry of this line, you would say the axis of symmetry is x equals negative 1. Now, that's the axis of symmetry, and that's the line that cuts a parabola in half. The vertex is going to be the very tippy top of that parabola, or the very bottom of the parabola. So how you find that is you take this number and you plug it into the equation, to the original equation. So I'm going to say y equals 2 times negative 1 squared plus 4 times negative 1 minus 3. So y equals negative 1 squared is 1 times 2 is 2 minus 4 minus 3. So y equals 2 minus 4 is negative 2 minus 3 is negative 5. So y equals negative 5. So now I have my axis of symmetry, which is x equals 1. And I know my vertex then would be negative 1 comma negative 5. That is the vertex. Okay, so how this comes in handy is when they ask you to graph a function, you don't have to make the table and fill in all the values. So this is the same function that we just did in that last problem. And so if I go back, I know that my axis of symmetry was x equals negative 1, and my vertex was negative 1, negative 5. So I can graph these, okay? X equals negative 1. Here is my axis of symmetry. And you'll notice that a lot of times they do it as like a dotted line, just so that it doesn't look like a linear equation. It's just an axis of symmetry. X equals negative 1. And my vertex is negative 1, negative 5. Negative 1, go over 1, down 5. So there's my vertex. Now, there's a couple more things that you need to do. You need to look. Well, I can't graph a parabola with one point, so I have to look back at my equation and look at the y-intercept. That is going to be your second point. So on my y, my second point is negative 3, which is right here. Now, you know an axis of symmetry cuts a parabola in half, so I know that there is a mirror image of that point on the other side of the axis of symmetry. So it just is exactly on the other side, and so now I know I can see what my parabola is going to look like. It's going to go up because this number is positive, so my parabola opens up, and then I have my 3 points. So then you're done. All right, if an object is given an initial upward velocity v and continues with no additional force of its own. So these are the science type of problems that you're going to have to be able to solve. They are in the form of a quadratic function. Now, here is an example. Aerial fireworks carry stars, which are made of a sparkler-like material. Upward, ignite them, and project them into the air in fireworks displays. Suppose a particular star is projected from an aerial firework at a starting height of 610. So this is a key number with initial upward velocity of 88 feet per second. So I need to plug those two numbers into this equation right here that they've given me. So I'm going to write out my equation. H equals negative 16 t squared plus velocity times t plus c. Now, I want the height. How far above the ground will it be? That's the question. Okay? So I am going to put in this as my t, 88 seconds. So negative 16 times 88 squared plus, oh wait, that's the velocity, I'm sorry. Negative 16 t squared plus 88t, there's where the velocity, that's velocity, plus 610. 610 was my starting height, and therefore this is your y-intercept. That's your starting point, okay? So then I have negative 16t squared plus 88t plus 610, and I need to find how far above the ground it will be. So what you have to do is you have to find your axis of symmetry, what your x is. So it's negative b over 2a. So this is a, this is b, this is c. So negative b would be negative 88 divided by 2 times negative 16. Sorry, had to grab my calculator. So now you have negative 88 divided by negative 32, and you get 2.75. Now, 2.75 is your x or your t. So what you do is you found that, and you're going to plug that in to this equation right here, and then that will give me my h. So I have negative 16 times 2.75 squared plus 88 times 2.75 plus 610. So whenever you're doing these, first step is to find your axis of symmetry, which is your 2.75. Now I have 2.75 squared times negative 16, and that is negative 121. Plus 88 times 2.75, which is 242, plus 610. And that equals 731 feet above the ground. So that rocket will go, or that firework will go 731 feet above the ground. Okay, last type of problem. Now, graph the quadratic inequality y is greater than negative x squared plus 6x minus 5. So, inequalities. These are kind of tricky. Essentially, you're doing the exact same thing. So my first thing I want to do is find the axis of symmetry. So negative b would be negative 6 over 2 times negative 1. Now, whenever you see this negative x squared, you want to just, I like to rewrite it like that because then I can see exactly what my a is. So I know that it's negative 1. So negative 6 over negative 2 is a positive 3. So I know my axis of symmetry is 3. X equals 3, so I'm going to make a dotted line at 3. This is my axis of symmetry. It's going to cut my parabola in half. And then I'm going to plug 3 into the equation. Negative 1 times 3 squared plus 6 times 3 minus 5. So negative 1 times 9 plus 18 minus 5. So this is negative 9 plus 18 minus 5. So that's 9 minus 5, which is 4. So now I know my vertex is 3, 4 right here. That is my vertex. And then if I look at my y-intercept is -5. And I know I have a mirror image on the other side of my axis of symmetry. So I count 3 spaces, stop, and then count 3 more, and that's my next point. And then this is going to open down because it has a -a value right here. This is negative, so any parabola that is negative opens down. Now, since I did my graphing, I have to go back and I have to look. Well, this is an inequality. And I look at my inequality sign and I say, oops, I accidentally made this a solid parabola when it really should be a dashed parabola. So you need to make sure it is a dashed parabola. And then it is everything greater than, because this sign right here is greater than. So how you shade is you're going to shade everything above the parabola because it's greater than. It's kind of different. So that is everything greater than. It's on top of it. All right, that's it for your notes.